Hello and welcome to the Dreamy Scientist. I'm so glad you're here tonight. Whether you're settling into bed, curling up somewhere cozy, or just letting the day slowly fade away, you've found yourself in the perfect place for a gentle journey into one of the most mysterious frontiers of science. Tonight, we're going to drift softly into the quantum realm, that strange, invisible universe that exists all around us and even within us, yet operates by rules so peculiar they seem almost like magic. It's a world where particles can be in two places at once, where empty space isn't really empty, and where the very act of looking at something changes what you're looking at. It's a realm so small that if an atom were the size of a football stadium, the quantum world we're exploring would be smaller than a marble rolling around on the field. Yet within this unimaginably tiny space lies the foundation of everything we see, touch, and experience. Before we begin our quiet exploration, I'd love to know where you're listening from tonight. Perhaps you're halfway across the world watching the stars appear, or maybe you're just a few blocks away from me settling in for the evening. Wherever you are, if you find these gentle science journeys soothing, I'd be grateful if you tapped the like button, subscribed, or simply left a comment about your corner of the world. It helps this little channel grow and brings more curious minds together for these peaceful expeditions into the wonders of science. Now, I do hope this video isn't so fascinating that it keeps you wide awake, but if it does, at least you'll drift off, having learned something remarkable about the hidden universe that surrounds us every moment of every day. So take a deep breath, let your shoulders relax, and let's begin our descent into the quantum realm, where the impossible becomes everyday reality and the smallest things reveal the grandest mysteries. What exactly is the quantum realm? It sounds like something from a science fiction movie, doesn't it? Yet it's as real as the device you're listening to this on, more real in fact, since every atom in that device, every electron flowing through its circuits, operates according to quantum mechanical principles. The quantum realm isn't a place you can visit like a distant planet. It's a scale of reality, a way of describing what happens when things become almost impossibly small. To understand just how small we're talking, imagine this: if you took a single drop of water and magnified it until it was the size of the entire Earth, then each molecule of water in that drop would be about the size of a marble. That's already incredibly tiny, but we're going even smaller than that. We're diving down to the level of individual atoms, and then deeper still to the subatomic particles that make up those atoms: electrons, protons, neutrons, and the even more exotic particles that dance within them. At this scale, the familiar rules of physics, the ones that govern our everyday world, begin to break down. Or perhaps it's more accurate to say they reveal their deeper, more fundamental nature. A baseball thrown across a field follows a predictable path. You can calculate exactly where it will land, but an electron moving through space doesn't behave like a tiny baseball. Instead, it exists in what scientists call a superposition, a ghostly state where it's simultaneously in multiple places until someone or something measures its position. This isn't just theoretical speculation. It's been demonstrated in countless experiments over the past century when scientists fire individual electrons through tiny slits in a barrier. Something extraordinary happens If they don't try to detect which slit the electron passes through, it somehow goes through both slits at the same time, creating an interference pattern on the other side, as if the single electron were interfering with itself. But the moment they set up detectors to see which path the electron actually takes, the interference pattern vanishes and the electron behaves like a normal particle going through just one slit. This is the famous double slit experiment, and it reveals one of the most mind-bending aspects of quantum mechanics. The act of observation fundamentally changes reality at the quantum scale. It's as if the quantum world exists in a state of infinite possibility until consciousness or measurement collapses those possibilities into a single outcome. But let's step back for a moment and consider how we even discovered this hidden realm. For most of human history, people assumed that if you could just build better and better microscopes, you could keep zooming in forever, seeing smaller and smaller details with perfect clarity. They imagined that atoms, if they existed at all, would be like tiny solar systems with electrons orbiting a central nucleus in neat, predictable paths. The first hint that reality might be stranger than this came in the early 1900s when scientists began studying how hot objects emit light. They expected the light to follow certain patterns based on classical physics, but instead they found that energy seemed to come in discrete packets or quanta, as if nature had a fundamental graininess to it. Max Planck, who first proposed this idea, was so uncomfortable with it that he spent years trying to find a way around it. Little did he know he was opening the door to an entirely new understanding of reality. Albert Einstein pushed this door wider when he explained the photoelectric effect, showing that light itself comes in particle-like packets called photons. This was puzzling because light had long been understood as a wave, yet here was evidence that it also behaved like particles. It was the first hint of wave-particle duality, one of the central mysteries of quantum mechanics. But the real revolution began with Niels Bohr's model of the atom, instead of electrons orbiting smoothly like planets. Bohr proposed that they could only exist at certain specific energy levels, jumping instantly from one level to another without ever existing in between these quantum leaps, as they came to be called, defied common sense. How could something move from point A to point C without passing through point B's, yet experimental evidence supported this bizarre idea. As more scientists dove into the quantum world, the strangeness only deepened. Werner Heisenberg discovered that there were fundamental limits to what could be known simultaneously about a particle's properties. The more precisely you measure its position, the less you can know about its momentum, and vice versa. This wasn't just a limitation of measurement tools. It was a fundamental feature of reality itself, uncertainty built into the very fabric of existence. Erwin Schrödinger developed mathematical equations to describe quantum systems, but he too was troubled by the implications. His famous thought experiment about a cat that could be simultaneously alive and dead was meant to highlight how absurd quantum mechanics seemed when applied to everyday objects. Yet his equations worked perfectly for describing the behavior of atoms and molecules. Louise de Broglie added another layer of mystery by proposing that not just light, but all matter has wave-like properties. An electron isn't just a particle, it's also a wave with a specific wavelength. This matter wave, as it's called, is usually too small to notice in large objects, but becomes significant at the atomic scale. Suddenly, the electron's quantum behavior began to make sense. It wasn't a tiny ball orbiting an atom, it was a standing wave wrapped around the nucleus like ripples on a pond. Max Born interpreted these mathematical waves in a revolutionary way. They didn't represent the actual position of a particle, but rather the probability of finding it at any given location. Quantum mechanics, he suggested, was fundamentally probabilistic, not deterministic. You couldn't predict exactly what would happen to an individual particle, only the statistical likelihood of various outcomes. This probabilistic nature troubled many scientists, including Einstein, who famously declared that God does not play dice with the universe, but the experimental evidence kept supporting quantum mechanics. No matter how counterintuitive it seemed, particles really did seem to exist in multiple states simultaneously. Reality really was fundamentally uncertain, and observation really did appear to collapse infinite possibilities into definite outcomes. As experimental techniques improved, scientists began to explore deeper into the quantum realm. They discovered that the seemingly empty space between atomic particles wasn't empty at all. It was filled with quantum fields rippling with virtual particles that popped in and out of existence faster than any detector could measure. They found that particles could become entangled, sharing properties across vast distances in ways that seemed to violate the speed of light limit. They observed quantum tunneling, where particles could pass through barriers that should be impossible to cross. According to classical physics, it was as if a ball could roll through a solid wall instead of bouncing off it. Yet this impossible behavior turned out to be essential for many natural processes, including the nuclear fusion that powers the sun without quantum tunneling. Stars couldn't shine, and life as we know it couldn't exist. The more scientists studied the quantum realm, the more they realized that this wasn't just an exotic corner of physics. It was the foundation upon which all of reality rested. Every chemical bond that holds molecules together relies on quantum mechanics. Every enzyme in your body works because of quantum effects. Every solar panel, every computer chip, every LED light depends on our understanding of quantum behavior. But perhaps the most remarkable discovery was that consciousness itself might be intimately connected to quantum mechanics. Some scientists began to wonder whether the act of observation that collapses quantum possibilities into definite outcomes might be related to consciousness itself. While this idea remains highly speculative, it raises profound questions about the nature of reality and our place within it. The quantum realm challenges our most basic assumptions about how the world works. It suggests that at the deepest level, reality is not made of solid, unchanging particles, but of possibilities, relationships, and information. It hints that the universe might be far more interconnected and mysterious than we ever imagined. As we prepare to dive deeper into this hidden world in the next part of our journey, remember that we're not just exploring abstract scientific concepts, we're uncovering the very foundation of existence itself. The strange rules that govern the quantum realm are the same rules that allowed the first stars to form the first complex molecules to assemble and ultimately the first conscious minds to emerge. Tonight, as you drift towards sleep, Consider this: so every atom in your body, every electron in your brain is obeying these quantum laws right now. You are quite literally made of quantum mechanics, walking, talking, breathing quantum phenomena. And tomorrow we'll explore even deeper into this hidden realm, discovering how quantum effects might influence everything from the way plants capture sunlight to the possibility of quantum computers that could revolutionize our world. The quantum realm isn't just the smallest scale of reality. It might be the key to understanding the deepest mysteries of existence itself, and we're only just beginning to unlock its secrets. But what does this quantum world actually look like if we could somehow shrink ourselves down and experience it directly? Imagine floating in a realm where the very concept of solid matter dissolves into something far more ethereal and strange. You wouldn't see tiny billiard balls bouncing around. Instead, you'd find yourself surrounded by clouds of probability, fuzzy regions where particles might be found if someone bothered to look. These probability clouds have names that sound almost poetic. Orbitals, they're called, and they come in beautiful three-dimensional shapes. Some look like spheres, others like dumbbells or flowers, each one representing the quantum dance of electrons around atomic nucleus. But here's what's truly remarkable. These aren't just mathematical abstractions. They're the actual shapes that determine how atoms bond with each other, how molecules form, and ultimately how all of chemistry works. In this quantum landscape, distance becomes negotiable. Particles can tunnel through walls that should stop them cold, as if the barriers were made of fog rather than solid matter. Imagine trying to bounce a tennis ball off a brick wall only to watch it occasionally appear on the other side without breaking the wall or even slowing down. This quantum tunneling happens countless times every second in the world around us. It's how the sun manages to fuse hydrogen atoms despite the enormous electrical forces trying to push them apart. The temperature in a star's core isn't quite hot enough to overcome the electromagnetic repulsion between positively charged protons, but quantum tunneling allows them to occasionally slip past these barriers and fuse together, releasing the energy that lights up our sky and warms our planet. Without this impossible quantum behavior, the universe would be a cold, dark place filled with hydrogen gas and little else. But perhaps the most alien aspect of the quantum realm is how particles seem to communicate with each other instantaneously across vast distances when two particles become entangled, a phenomenon Einstein called spooky action. At a distance, measuring the properties of one immediately affects the other, no matter how far apart they are. This isn't like two synchronized clocks ticking in unison. Instead, it's as if the particles remain fundamentally connected, sharing a single quantum state, even when separated by light years. Scientists have tested this entanglement in laboratories around the world, sending entangled photons across cities and even between Earth and satellites. The results consistently confirm what quantum mechanics predicts. Measuring one particle instantly determines the state of its partner faster than light could travel between them. This doesn't violate relativity because no information is actually transmitted, but it does suggest that our intuitive notions of separateness and locality break down at the quantum level. The quantum realm operates on principles so foreign to our everyday experience that even the language we use to describe it becomes inadequate. We talk about particles and waves, But quantum entities are neither, and both simultaneously. We speak of position and momentum, but these properties don't exist independently in the quantum world. They're contextual, emerging only in the act of measurement. Consider the humble electron orbiting an atom in the classical view. It would trace a definite path like a planet around the sun, but quantum mechanics tells us there is no path. The electron exists as a standing wave, a pattern of probability that surrounds the nucleus. Only when we measure its position does it appear to be in one specific place, and even then the measurement disturbs the system, changing what we're trying to observe. This observer effect isn't limited to scientific instruments. Any interaction that reveals information about a quantum system counts as a measurement. A photon of light bouncing off an electron to reveal its position transfers energy and momentum, changing the electron's state. The quantum world seems to exist in a delicate balance between possibility and actuality, with consciousness, or at least information gathering, playing a fundamental role in determining which possibilities become real. But the quantum realm isn't just about tiny particles behaving strangely. It's also about fields, invisible entities that permeate all of space. These quantum fields are like invisible oceans, with particles appearing as ripples or waves on their surfaces. The electromagnetic field gives rise to photons. The electron field creates electrons, and so on. Even empty space isn't truly empty, but filled with these quantum fields constantly fluctuating at the smallest scales. These vacuum fluctuations, as they're called, create virtual particles that pop into existence for the briefest instants before disappearing again. They're called virtual because they can't be directly detected, but their effects are real. They contribute to the energy of empty space. They influence the behavior of real particles, and they might even play a role in the expansion of the universe itself. The Casimir effect demonstrates how these virtual particles can produce measurable forces when two metal plates are placed very close together in a vacuum. The virtual particles between them are restricted to certain wavelengths, while those outside the plates can have any wavelength. This creates a slight pressure that pushes the plates together, a force generated by nothing more than the quantum fluctuations of empty space. As we venture deeper into this quantum landscape, we begin to see how it connects to the larger structures of reality. Quantum mechanics explains why atoms have the sizes they do, why certain elements are stable while others decay radioactively, and why the periodic table has the structure it does. The electron shells that determine chemical properties are direct consequences of quantum wave behavior. The bizarre rules of the quantum realm also explain why matter doesn't collapse under its own weight. According to classical physics, electrons should spiral into the nucleus, losing energy as they orbit. But quantum mechanics forbids this through the Pauli exclusion principle, which states that no two electrons can occupy exactly the same quantum state. This quantum mechanical pressure prevents atoms from collapsing and gives matter its bulk and solidity. Even the colors we see around us are quantum phenomena. When an electron absorbs energy, it jumps to a higher orbital. When it falls back down, it emits a photon of light with a very specific energy and therefore a specific color. The brilliant red of a ruby, the deep blue of a sapphire, the green glow of an aurora all arise from electrons making quantum leaps between energy levels. But the quantum realm extends beyond individual atoms and molecules. Recent discoveries have revealed quantum effects in biological systems that were once thought too warm and noisy to sustain quantum coherence. Photosynthesis, the process by which plants convert sunlight into chemical energy, appears to use quantum superposition to find the most efficient pathways for energy transfer. Birds may navigate using quantum entanglement in specialized proteins in their eyes, allowing them to literally see the Earth's magnetic field. Some researchers even speculate that consciousness itself might involve quantum processes in the brain. Though this remains highly controversial, the quantum realm might not be confined to laboratories and abstract theories. It could be woven into the very fabric of life and mind. As we float through this invisible universe of probability and possibility, we begin to understand that the quantum realm isn't separate from our everyday world. It is our everyday world viewed through the proper lens. Every breath you take, every heartbeat, every thought involves countless quantum processes. The apparent solidity of matter, the flow of electricity through your nervous system, the chemical reactions that power your cells all depend on the strange rules that govern the smallest scales of reality. The quantum realm challenges us to expand our definition of what's possible and what's real. It suggests that the universe is far more mysterious, interconnected, and dynamic than our senses reveal. It hints at deeper layers of reality that we're only beginning to explore, and it raises profound questions about the nature of information, consciousness, and existence itself. Tomorrow we'll journey even further into this hidden world, discovering how scientists are learning to harness quantum effects to build technologies that seemed like pure fantasy just decades ago. Quantum computers that could solve certain problems faster than all the classical computers on Earth, combined quantum sensors, so sensitive they can detect individual photons or measure gravitational waves from colliding black holes, quantum communication systems that could provide absolutely secure information transfer using the fundamental laws of physics themselves. But for now, as you prepare to rest, let yourself marvel at the fact that you are a walking, talking quantum mechanical system. Every cell in your body is a complex quantum orchestra with countless particles dancing to the strange rhythms of probability and possibility. You are made of the same stuff as the stars, governed by the same mysterious laws that allow particles to tunnel through barriers and exist in multiple places at once. The quantum realm isn't just the foundation of matter, it's the foundation of mystery itself, reminding us that no matter how much we learn about the universe, there are always deeper questions waiting to be asked. And perhaps the most beautiful part of all is that this hidden world of infinite possibility is always there, just beneath the surface of everything you see and touch, patiently waiting for curious minds to discover its secrets. The quantum realm holds secrets that stretch far beyond what we've explored so far, and as we drift deeper into this invisible universe, we encounter phenomena that challenge not just our understanding of physics, but our very conception of reality itself. One of the most profound discoveries in quantum mechanics is that the act of measurement doesn't just reveal properties that were already there, it actually creates them. Imagine trying to photograph a ghost that only becomes solid when you point the camera at it. In the quantum world, this isn't just a metaphor, it's how reality actually works. Before measurement, particles exist in what physicists call a superposition of states, a kind of quantum limbo where all possible outcomes coexist simultaneously. An electron doesn't have a definite spin until you measure it. A photon doesn't follow a specific path until you detect it, and according to some interpretations, the entire universe might exist in superposition until conscious observers collapse the wave function into definite reality. This leads us to one of the most beautiful and unsettling ideas in all of science, the many worlds interpretation proposed by physicist Hugh Everett. According to this view, every time a quantum measurement occurs, the universe splits into multiple parallel realities, each one containing a different outcome. In one world, the electron spins up. In another, it spins down, and both worlds are equally real. If this interpretation is correct, then there are countless versions of you scattered across an infinite multiverse, each one living out slightly different variations of your life. The mathematics of quantum mechanics seems to support this wild possibility, but it raises profound questions about the nature of existence. Are all these parallel worlds equally real? Do other versions of yourself have the same subjective experiences you do? And perhaps most mysteriously, why do we only experience one branch of this vast quantum tree of possibilities? But the strangeness of the quantum realm extends even deeper into the nature of time itself. In our everyday world, time flows in one direction from past to future. Cause precedes effect, and yesterday's events influence today's outcomes. But in the quantum world, the arrow of time becomes blurred and sometimes even reversed. Experiments have shown that quantum systems can exhibit what's called retrocausality, where measurements performed in the future can influence the behavior of particles in the past. Consider the delayed choice quantum eraser experiment, a mind-bending demonstration that pushes the boundaries of what we think we know about causality. Photons are sent through a double-slit setup, but the decision of whether to measure which path they took is made long after the photons have already passed through the slits. Remarkably, this future decision retroactively determines whether the photons behaved like waves or particles in the past. It's as if the universe maintains a kind of quantum accounting system, where the books aren't balanced until all measurements are complete, regardless of when they occur. This temporal weirdness suggests that the past might not be as fixed as we imagine. In a quantum universe, history itself might exist in superposition until observation collapses it into a definite sequence of events. The implications are staggering. If our measurements today can influence quantum events in the past, then the present moment takes on a cosmic significance as a point where infinite possibilities crystallize into definite reality. As we venture further into the quantum landscape, we encounter another profound mystery: the relationship between information and physical reality. In classical physics, information is something that describes matter and energy, but in quantum mechanics, information seems to be more fundamental than the physical systems themselves. Some physicists now believe that reality is literally made of information, with matter and energy being mere expressions of underlying quantum data. This idea, known as it from bit, suggests that every physical process can be understood as a computation, every particle as a quantum bit of information, and every interaction as an exchange of data. If this is true, then the universe might be less like a giant machine and more like a cosmic computer, processing information at the most fundamental level of reality. The quantum realm also reveals surprising connections between seemingly unrelated phenomena through the principle of complementarity. Just as light exhibits both wave and particle properties depending on how you observe it, many aspects of quantum systems come in complementary pairs. Position and momentum, energy and time, wave and particle, these aren't just different ways of describing the same thing. They're fundamentally incompatible aspects of reality that can never be observed simultaneously. Niels Bohr extended this idea beyond physics, suggesting that complementarity might be a universal principle governing all knowledge and experience. Perhaps consciousness and the unconscious mind are complementary aspects of awareness, or maybe free will and determinism are complementary descriptions of human behavior. The quantum world teaches us that reality might be too rich and complex to be captured by any single perspective, requiring multiple complementary viewpoints to approach a complete understanding. But perhaps the most mysterious aspect of the quantum realm is how it gives rise to the classical world we experience every day. If particles can exist in multiple places simultaneously, why don't we see quantum superpositions in everyday objects? If measurement creates reality, why does the world seem to exist independently of our observations? This puzzle, known as the quantum to classical transition, remains one of the deepest mysteries in physics. The answer seems to lie in a process called decoherence, where quantum systems become entangled with their environment, causing superpositions to rapidly collapse into definite states. Large objects contain so many particles interacting with so many environmental factors that their quantum behavior is immediately scrambled, creating the appearance of classical physics. It's like trying to maintain a delicate sand castle while waves constantly wash over it. The quantum coherence is there in principle, but it's destroyed too quickly to observe. Yet even in our classical world, quantum effects occasionally peek through. The stability of matter itself depends on quantum mechanics. Without the Pauli exclusion principle, all electrons would collapse into the lowest energy state, and atoms would cease to exist. The conductivity of metals, the hardness of diamond, the flexibility of rubber, all these everyday properties emerge from quantum mechanical interactions between atoms and electrons. The quantum realm also helps explain one of the most profound questions in cosmology. Why does the universe contain more matter than antimatter? According to our current understanding, the Big Bang should have created equal amounts of matter and antimatter, which would have annihilated each other completely, leaving behind a universe filled with nothing but radiation. The fact that we exist at all suggests that some subtle asymmetry favored matter over antimatter in the early universe. This asymmetry might arise from quantum mechanical processes that violate certain symmetries in nature. The discovery of CP violation, where certain particle interactions distinguish between matter and antimatter, provides a possible explanation for our matter-dominated universe. Once again, the strange rules of the quantum realm turn out to be essential for the existence of stars, planets, and life itself. As our understanding of quantum mechanics has deepened, scientists have begun to realize that the quantum realm might hold the keys to solving some of the greatest puzzles in physics. The nature of dark matter and dark energy, which together make up 95% of the universe, might be explained by exotic quantum fields that interact only weakly with ordinary matter. The unification of quantum mechanics with gravity, one of the holy grails of theoretical physics, might require us to understand how space and time themselves emerge from more fundamental quantum processes. Some theories suggest that space-time is not continuous, but made up of discrete quantum units, tiny pixels of reality at the Planck scale, trillions of times smaller than a proton. At this unimaginably small scale, the familiar concepts of distance and duration might break down completely, replaced by a foam-like structure where virtual particles constantly pop in and out of existence, and the geometry of space itself fluctuates wildly. The quantum realm continues to surprise us with phenomena that seem to violate our most basic intuitions about reality. Quantum teleportation allows the complete information content of a particle to be transmitted instantly across any distance, though the particle itself is destroyed in the process. Quantum cryptography uses the fundamental laws of physics to create communication systems that are theoretically impossible to hack. Quantum sensors can detect changes so small they approach the limits set by the uncertainty principle itself. But perhaps most remarkably, the quantum realm suggests that consciousness and physical reality might be more intimately connected than we ever imagined. While the role of consciousness in quantum mechanics remains hotly debated, some researchers propose that awareness itself might be a fundamental feature of the universe, not just something that emerged from complex arrangements of matter and energy. This idea, sometimes called panpsychism, suggests that even elementary particles might have rudimentary forms of experience, and that consciousness as we know it emerges when these micro-experiences combine in sufficiently complex systems. If true, this would mean that the boundary between mind and matter, between observer and observed, is not as clear-cut as we once believed. The quantum realm challenges us to expand our definition of what's real and what's possible. It suggests that the universe is far stranger, more interconnected, and more mysterious than our everyday experience suggests. Every breath you take, every heartbeat, every thought involves countless quantum processes operating according to rules that defy common sense yet govern the deepest levels of reality. As we prepare to explore even further into this hidden universe, remember that we're not just studying abstract physics, we're uncovering the fundamental nature of existence itself. The quantum realm is not separate from your daily life. It is your daily life, viewed through the lens of ultimate reality. Tomorrow, we'll discover how scientists are learning to harness these quantum mysteries to build technologies that could revolutionize our world and perhaps even our understanding of what it means to be human. As we drift even deeper into the quantum realm, we encounter what might be the most extraordinary discovery of all, the realization that this hidden universe isn't just governing the behavior of particles in distant laboratories. It's actively shaping the world of living things in ways that scientists are only beginning to understand. The warm, wet, noisy environment inside biological cells was long thought to be far too chaotic to sustain the delicate quantum effects we've been exploring. Yet recent discoveries suggest that life itself might be a quantum phenomenon. Consider the remarkable efficiency of photosynthesis, the process by which plants convert sunlight into chemical energy with an effectiveness that surpasses our most advanced solar panels. For decades, Scientists assumed this was simply a matter of clever chemistry and evolutionary optimization. But when researchers began studying photosynthesis at the quantum level, they discovered something astonishing. The energy from absorbed photons doesn't follow a single path through the plant's molecular machinery. Instead, it explores multiple pathways simultaneously, existing in quantum superposition until it finds the most efficient route to its destination. It's as if the plant's cells are performing quantum calculations, using superposition to sample all possible energy transfer routes at once and automatically selecting the optimal path. This quantum coherence persists for surprisingly long periods, even in the warm, chaotic environment of living tissue. The discovery suggests that evolution hasn't just stumbled upon quantum mechanics, it has learned to harness it as a tool for survival. But photosynthesis is just the beginning. Birds that migrate thousands of miles with pinpoint accuracy may be using quantum entanglement as their compass. Specialized proteins in their eyes, called cryptochromes, appear to be sensitive to the Earth's magnetic field through quantum mechanical processes. When light strikes these proteins, it creates pairs of entangled electrons whose spin states are influenced by magnetic fields. The birds may literally see magnetic field lines as patterns of light and shadow overlaid on their visual world, a quantum-enhanced navigation system that puts our GPS satellites to shame. Even more intriguingly, some researchers propose that consciousness itself might emerge from quantum processes in the brain. The idea is controversial and far from proven, but it offers a tantalizing possibility for understanding one of the deepest mysteries of existence. If consciousness does involve quantum mechanics, it would mean that the strange rules governing the smallest scales of reality play a direct role in generating your thoughts, memories, and sense of self. The quantum realm also reveals profound connections between mind and mathematics that hint at deeper truths about the nature of reality. The equations that describe quantum behavior are written in the language of complex numbers, mathematical objects that include the square root of -1. These numbers have no direct physical meaning in our classical world, yet they're essential for understanding quantum mechanics. It's as if the universe speaks in mathematical poetry, using abstract symbols to describe the most fundamental aspects of existence. This mathematical beauty extends to the symmetries that govern quantum systems. The same mathematical structures that describe the behavior of subatomic particles also appear in crystallography, music theory, and even artistic patterns. It's as if there's a hidden mathematical harmony underlying all of reality, a cosmic music that plays out at every scale from the quantum realm to the largest structures in the universe. But perhaps the most profound implication of quantum mechanics is what it tells us about the nature of existence itself. In the classical worldview, objects have definite properties independent of observation. A rock has a specific weight, a specific color, a specific temperature, regardless of whether anyone measures these properties. But quantum mechanics suggests that this common sense view is fundamentally wrong. Properties don't exist independently of measurement. They emerge from the relationship between observer and observed. This doesn't mean that reality is purely subjective or that we create the world through our thoughts. Rather, it suggests that reality is relational, existing in the connections and interactions between different parts of the universe. You don't just observe the quantum world, you participate in it. Every measurement you make, every photon that strikes your eye, every interaction between your body and the environment around you is part of the ongoing creation of reality. The implications ripple outward in surprising directions. If properties emerge from relationships rather than existing independently, then perhaps consciousness, life, and even love are not things that exist in isolation, but patterns of relationship that emerge from the deeper quantum substrate of reality. The boundaries between self and world, between mind and matter, between observer and observed, may be far more fluid than we imagine. This relational view of reality also sheds new light on some of the deepest questions in physics and philosophy. The fine-tuning problem, why the fundamental constants of nature seem perfectly calibrated to allow for the existence of stars, planets, and life, might be resolved if we recognize that these constants don't exist independently, but emerge from the quantum relationships that constitute reality. The universe isn't fine-tuned for life, so much as life and universe co-create each other through quantum mechanical interactions. As we explore these deeper layers of the quantum realm, we begin to see how it connects to questions that have puzzled humanity for millennia. What is the relationship between mind and matter? How does consciousness arise from physical processes? What is the nature of time, space, and causality? The quantum world doesn't provide simple answers to these questions, but it does offer new ways of thinking about them that transcend the old divisions between science and philosophy, between objective and subjective, between physical and mental. The quantum realm teaches us that reality is far more creative, dynamic, and interconnected than our everyday experience suggests. Every atom in your body is engaged in a constant dance of quantum interactions, exchanging energy and information with the world around it. You are not a separate object moving through space, but a pattern of quantum relationships temporarily organized into the experience of being human. This perspective transforms our understanding of what it means to be alive and conscious in a quantum universe. Your thoughts and experiences aren't just private mental events happening inside your head. They're part of the ongoing quantum conversation between mind and world. When you observe a sunset, quantum interactions in your retina trigger cascades of neural activity that somehow give rise to the subjective experience of beauty. When you remember a loved one, quantum processes in your brain reconstruct patterns of information that connect you across time and space to moments of shared experience. The quantum realm also suggests new possibilities for human potential and technological development. As we learn to work with quantum effects rather than against them, we may discover ways to enhance human consciousness, extend our sensory capabilities, or even establish deeper connections with the natural world. Some researchers speculate about quantum-enhanced intuition, where the brain's quantum processes might allow us to access information in ways that transcend normal sensory channels. But even without exotic new abilities, simply understanding our quantum nature changes how we relate to the world around us. Every breath you take involves countless quantum mechanical processes. The oxygen molecules binding to hemoglobin in your blood, the electron transport chains in your cellular mitochondria, the neural quantum tunneling that enables your thoughts. All of these depend on the strange rules we've been exploring. The water in your body, the same H2O molecules that have been cycling through the Earth's oceans and atmosphere for billions of years, maintains its liquid structure through quantum mechanical hydrogen bonds. The carbon atoms in your DNA, forged in the nuclear furnaces of ancient stars through quantum tunneling processes, carry the information patterns that make you uniquely you. You are quite literally made of quantum mechanics, a walking, talking expression of the fundamental laws that govern reality at its deepest level. As we prepare to venture even further into this quantum landscape, consider the profound implications of what we've discovered. The hidden world inside the quantum realm isn't separate from your daily experience. It is your daily experience viewed from the perspective of ultimate reality. Every sensation, every emotion, every moment of awareness emerges from the quantum substrate that underlies all existence. Tomorrow, we'll explore how scientists are learning to harness these quantum mysteries to build technologies that could reshape our world, quantum computers that could solve problems beyond the reach of classical machines, quantum sensors that could detect the faintest whispers of gravitational waves, and quantum communication systems that could connect minds across vast distances. But for now, as you drift toward rest, let yourself marvel at the fact that you are a quantum being in a quantum universe, participating moment by moment in the ongoing creation of reality itself. The quantum realm reminds us that the universe is far more mysterious and wonderful than our everyday senses reveal. It challenges us to expand our imagination, to embrace uncertainty and paradox, and to recognize that the deepest truths about existence may be found not in what we can see and touch, but in the invisible relationships and possibilities that dance beneath the surface of everything we think we know. Tonight, as we drift deeper into this quantum tapestry, we encounter perhaps the most breathtaking realization of all, that the quantum realm isn't just a collection of strange phenomena happening in isolation, but a unified field of pure potentiality from which all of reality continuously emerges. Think of it as an invisible ocean of possibility that surrounds and permeates everything, an ocean where waves of probability lap against the shores of actuality, occasionally crystallizing into the solid world we experience with our senses. This quantum field is an empty space waiting to be filled with particles and forces. Instead, it's a dynamic, living entity that bubbles with constant activity. Virtual particles dance in and out of existence faster than the blink of an eye, borrowing energy from the future and paying it back before the universe's accounting system notices the discrepancy. These fleeting phantom particles aren't just mathematical curiosities. They have real effects on the world around us, subtly influencing the behavior of matter and energy in ways that cascade upward from the quantum scale to shape the properties of everything we see and touch. Imagine standing at the edge of a vast lake on a perfectly still night. The surface appears smooth and motionless, but if you could see with quantum eyes, you would witness an endless choreography of tiny ripples and waves, each one representing a virtual particle pair spontaneously appearing and disappearing. Now imagine that this lake exists everywhere at once, not just in the spaces between atoms, but woven through the very fabric of space and time itself. This is the quantum vacuum, the foundation upon which all existence rests. But the quantum realm reveals something even more extraordinary about the nature of reality. It suggests that the distinction between something and nothing, between existence and non-existence, may be far more subtle than we ever imagined. In the quantum world, empty space isn't truly empty, and solid matter isn't truly solid. Instead, there's a spectrum of being that ranges from pure possibility to actualized reality, with countless gradations in between. Consider the quantum tunneling effect we explored earlier, where particles pass through barriers they shouldn't be able to cross. This isn't just a curiosity of subatomic physics, it's a window into a deeper truth about the nature of existence itself. The barriers aren't really solid walls, but probability distributions, regions where it becomes increasingly unlikely, but never impossible for a particle to be found. Reality, it seems, is built on likelihoods rather than certainties, on tendencies rather than absolutes. This probabilistic foundation extends far beyond individual particles to encompass the largest structures in the cosmos. The quantum fluctuations that occurred in the first fraction of a second after the Big Bang grew into the cosmic web of galaxies and galaxy clusters we observe today. The slight variations in density that quantum mechanics produced on unimaginably small scales expanded with the universe to become the seeds from which stars, planets, and ultimately life itself emerged. In a very real sense, you exist because of quantum uncertainty amplified across billions of years of cosmic evolution. The quantum realm also reveals profound insights about the nature of information and its relationship to physical reality. In classical physics, information is just a description of matter and energy, a kind of label we attach to physical systems to keep track of their properties. But quantum mechanics suggests something far more radical, that information might be the fundamental substrate of reality itself, with matter and energy being emergent properties of underlying quantum information. This perspective, known as quantum information theory, treats every physical process as a form of computation. When particles interact, they're not just exchanging energy and momentum, they're processing information, performing calculations that determine the outcome of their encounter. The entire universe becomes a vast quantum computer, continuously running algorithms written in the language of probability and possibility. But what kind of computation is the universe performing? Some physicists speculate that it might be calculating its own future, exploring all possible paths through the landscape of quantum states and selecting the ones that minimize certain fundamental quantities, like action or entropy. If this is true, then the flow of time itself might emerge from the universe's ongoing computation, with each moment representing the completion of another step in a cosmic calculation that began with the Big Bang. This computational view of reality has profound implications for our understanding of consciousness and free will. If the brain is a quantum information processing system, then thoughts and decisions might arise from quantum calculations that explore multiple possibilities simultaneously before collapsing into definite choices. The feeling of making a free choice might correspond to the moment when quantum superposition collapses and one possibility becomes actualized while others fade into the realm of what might have been. But the quantum realm doesn't just challenge our understanding of individual consciousness, It also raises tantalizing questions about collective consciousness and the possibility of non-local connections between minds. If quantum entanglement can create instantaneous correlations between particles separated by vast distances, might similar phenomena occur between conscious beings? Some researchers have begun investigating whether group meditation, shared emotional experiences, or even telepathic connections might involve quantum mechanical processes. While these ideas remain highly speculative, they point to a deeper truth about the interconnected nature of reality revealed by quantum mechanics. The classical worldview sees the universe as a collection of separate objects interacting through forces across space. But the quantum worldview suggests something more profound, that separation itself might be an illusion, and that all of reality is woven together into a seamless whole through quantum correlations and entanglements. This interconnectedness extends to the relationship between past, present, and future. In the quantum realm, time isn't a river flowing in one direction, but more like a vast ocean where waves from different temporal shores can interfere with each other. Quantum mechanics allows for scenarios where effects precede their causes, where future events influence past outcomes, and where the very distinction between before and after becomes ambiguous. The delayed choice quantum eraser experiments we touched on earlier demonstrate this temporal flexibility in action. The decision of whether to measure a particle's path can be made long after the particle has completed its journey. Yet this future decision retroactively determines how the particle behaved in the past. It's as if the universe maintains a kind of quantum credit system where events can occur on borrowed reality that gets paid back when observations finally collapse the wave function. This temporal non-locality suggests that our usual notion of causality might be too restrictive to capture the full richness of quantum reality. Perhaps cause and effect aren't linked in simple chains, but form complex networks where influences can flow backward and forward through time, creating feedback loops and self-consistent histories that transcend our linear perception of temporal flow. As we explore these deeper mysteries of the quantum realm, we begin to see how it connects to some of the most profound questions about the nature of existence. Why does anything exist rather than nothing? Why do the laws of physics have the particular forms they do? Why is the universe comprehensible to conscious minds like ours? The quantum perspective suggests that these questions might not have simple answers because they're based on assumptions about the independence of existence, laws, and consciousness that quantum mechanics calls into question. Instead of asking why the universe exists, we might need to ask how existence, consciousness, and physical law co-create each other through quantum mechanical processes. The universe might not be a pre-existing stage on which the drama of existence unfolds, but rather an ongoing improvisation where reality, awareness, and natural law emerge together from more fundamental quantum relationships. This co-creative view of reality places consciousness not as a late arrival in cosmic evolution, but as a fundamental aspect of existence itself. Every observation, every measurement, every moment of awareness participates in the ongoing creation of reality. You're not just living in the universe, you're helping to create it through your quantum mechanical interactions with the world around you. The implications ripple outward in directions we're only beginning to explore. If consciousness plays a fundamental role in quantum mechanics, then the emergence of life and intelligence in the universe might not be an unlikely accident, but an inevitable expression of reality's quantum nature. The universe might be biased toward consciousness, not because of fine-tuning, but because awareness is woven into the fabric of quantum existence itself. As we drift toward the conclusion of tonight's exploration, consider the profound shift in perspective that quantum mechanics offers. The hidden world inside the quantum realm isn't separate from your daily experience, but is your daily experience viewed from the deepest possible level of understanding. Every breath you take, every heartbeat, every moment of consciousness emerges from quantum processes that connect you to the fundamental creativity of the universe itself. The quantum realm teaches us that reality is far more mysterious, interconnected, and dynamic than our senses suggest. It challenges us to embrace uncertainty as a creative force, to see relationships as more fundamental than things, and to recognize that consciousness and cosmos are partners in an ongoing dance of mutual creation. Tomorrow, we'll discover how scientists are learning to work with these quantum mysteries to build technologies that could transform our world in ways that seem almost magical. But for now, as you settle into rest, let yourself marvel at the quantum symphony playing out in every cell of your body, every neuron of your brain, every heartbeat that connects you to the vast web of quantum relationships that is reality itself. You are not separate from the quantum realm. You are an expression of it, a temporary pattern of quantum information experiencing itself subjectively, a conscious wave in the infinite ocean of possibility that underlies all existence. The quantum realm stretches beyond even these profound mysteries, revealing layers of reality so fundamental they challenge the very language we use to describe existence. As we drift deeper into this invisible universe, we encounter what might be the most remarkable discovery of all. The quantum realm doesn't just contain the building blocks of matter and energy, it appears to be the source of space and time themselves. Imagine trying to understand a symphony by examining individual notes in isolation, never hearing how they weave together to create melody and harmony. For centuries, physicists approached reality this way, studying particles and forces as separate entities moving through a pre-existing stage called space-time. But quantum mechanics reveals something far more extraordinary. The stage itself might be emerging from the quantum interactions of its players at the smallest conceivable scales, trillions of times smaller than an atomic nucleus. The smooth fabric of space-time that Einstein described begins to break down into what physicists call quantum foam. Here, the very concepts of distance and duration lose their meaning, replaced by a churning sea of probability where virtual particles and antiparticles spontaneously appear and vanish, where space itself expands and contracts in random fluctuations, and where time moves not in a steady flow, but in discrete quantum ticks like frames in a cosmic movie. This quantum foam isn't empty nothingness, but a dynamic medium of pure potentiality from which the larger structures of reality crystallize. Just as ice forms from water when temperature drops below a critical point, space-time itself might emerge from quantum foam when certain conditions align. The smooth, continuous space and time we experience in our daily lives would then be like the calm surface of an ocean, hiding the turbulent quantum activity churning beneath. But the implications reach even further. If space and time emerge from quantum processes, then the universe's expansion, the formation of galaxies, and even the arrow of time itself might be expressions of underlying quantum computation. The cosmos becomes not just a vast machine following predetermined laws, but a creative system continuously calculating its own evolution, exploring infinite possibilities, and actualizing the most probable outcomes. Consider how this transforms our understanding of cosmic history. The Big Bang wasn't an explosion in empty space, but the moment when quantum foam first crystallized into the space-time we inhabit. The cosmic microwave background radiation that fills the universe carries the fingerprints of quantum fluctuations from that primordial moment, frozen echoes of probability waves that shaped the distribution of matter and energy across billions of light years. Even more remarkably, the quantum origin of space-time suggests that the universe might be fundamentally computational in nature. Each quantum interaction processes information, each measurement collapses probability waves into definite outcomes, and the sum total of all these quantum calculations generates the flow of time and the expansion of space. Reality becomes an ongoing conversation between possibility and actuality, with consciousness serving as both participant and witness to this cosmic computation. The quantum realm also reveals surprising connections between the very large and the very small through what physicists call the holographic principle. This idea suggests that all the information contained within any region of space can be encoded on its boundary, like a hologram that contains a three-dimensional image on a two-dimensional surface. If true, this means the entire universe might be a holographic projection from information encoded on its cosmic horizon. This holographic nature of reality helps explain some of the deepest puzzles in physics, such as the information paradox of black holes. When matter falls into a black hole, what happens to the quantum information it carries? The holographic principle suggests that this information isn't lost, but remains encoded on the black hole's surface, creating a quantum entanglement between the interior and exterior that preserves information even as matter disappears beyond the event horizon. But perhaps the most profound implication of the holographic principle is what it suggests about consciousness itself. If reality is fundamentally informational, and if consciousness involves the processing of quantum information, then awareness might not be confined to biological brains, but could be a basic feature of the holographic structure of space-time itself. Every region of the universe might possess a rudimentary form of experience, with complex consciousness emerging when these micro-experiences organize into sufficiently intricate patterns. This leads us to one of the most breathtaking possibilities revealed by quantum mechanics, that consciousness and cosmos might be two aspects of a single, underlying reality. The quantum field that gives rise to particles and forces might also give rise to awareness and experience. The wave function that describes the probability of finding a particle in any location might simultaneously describe the probability of a conscious experience occurring in any moment. If this is true, then the observer effect in quantum mechanics takes on an entirely new significance. When consciousness collapses a wave function, it's not just revealing pre-existing properties, but actively participating in the creation of reality. Every moment of awareness becomes a creative act, a collaboration between mind and universe in the ongoing improvisation of existence. The quantum realm teaches us that the boundaries we perceive between different aspects of reality, between matter and mind, between space and time, between self and world, might be conveniences of perception rather than fundamental divisions. At the deepest level, everything appears to be woven together into a seamless tapestry of quantum relationships, a unified field of being from which all diversity and complexity emerge. This unified perspective transforms how we understand our place in the cosmos. You're not a separate observer looking out at an independent universe, but a focal point of cosmic awareness, a place where the universe becomes conscious of itself. Your thoughts and experiences aren't private mental events happening inside your head, but expressions of the same quantum processes that govern stars, galaxies, and the expansion of space itself. The quantum realm also suggests that creativity and novelty are built into the fabric of existence. Unlike classical physics, which portrayed the universe as a deterministic machine grinding out predictable outcomes, quantum mechanics reveals a cosmos that's inherently creative, continuously exploring new possibilities and bringing unprecedented forms into being. The spontaneous appearance of virtual particles, the random collapse of wave functions, the emergence of complex structures from simple rules, all point to creativity as a fundamental force in nature. This quantum creativity extends to the evolution of life and consciousness. Rather than being unlikely accidents in an otherwise lifeless universe, living systems might be natural expressions of quantum creativity, self-organizing patterns that emerge when information processing reaches sufficient complexity. The same quantum processes that give rise to atoms and molecules also give rise to cells, ecosystems, and thinking beings. Even the process of scientific discovery itself might be an expression of quantum creativity. When researchers make breakthrough discoveries, they often describe moments of sudden insight that seem to come from nowhere, as if new understanding simply crystallizes out of the quantum foam of possibility. The human mind, operating through quantum processes in the brain, might be able to access information in ways that transcend normal sensory channels. As we explore these ultimate depths of the quantum realm, we begin to tapping into the deeper patterns that connect all aspects of reality. See how it addresses some of the most fundamental questions that have puzzled humanity throughout history. The quantum perspective suggests that existence itself is not a problem to be solved, but an ongoing creative process to be participated in. Reality is not a fixed structure to be discovered, but a dynamic system continuously bringing itself into being through the interaction of consciousness and quantum possibility. The strange rules that govern the quantum world, from superposition to entanglement to curious features of sub-the-observer effect, are not just atomic physics, but expressions of the creative principles that generate all of existence. When particles systems remain mysteriously connected, when observation exists in multiple states simultaneously, when separate creates reality, we're witnessing the fundamental creativity of the cosmos in action. This creativity extends to you as well. Every moment of your conscious experience represents a collapse of quantum possibilities into actualized reality. Every choice you make, every thought you think, universe, You are quite literally a co-creator of every emotion you feel, participates in the ongoing creation of the reality, working in partnership with the quantum field to bring new forms of existence into being. The hidden world inside the quantum realm is not separate from your daily life, but is the deepest truth about what countless quantum interactions. Every sensation you experience, and your daily life actually is. Every breath you take involves you form, relies on quantum effects in your brain cells. You are not just living in a quantum universe, just from quantum processes in your nervous system. Every memory, you are a quantum universe, temporarily organized into the conclusion of tonight's journey. Consider the profound gift that quantum mechanics offers. It of awareness that experiences itself as you. As we prepare to drift, Tor reveals a universe that is not cold, mechanical, and separate from consciousness, but warm, creative, and intimately connected to awareness itself. The quantum realm shows us that we live in a cosmos where mind yourself feel the quantum creativity flowing through every cell of your body, every in matter, possibility, and actuality. Self and world are different facets of a single, our understanding of what's possible. But tonight, as you settle into rest, let how scientists are learning to harness these quantum mysteries to build technologies that could transform underlying creative process. Tomorrow we'll explore synapse of your brain, every heartbeat that connects you to the infinite field of possibility from which all existence springs. You are not separate from the mystery you've been exploring tonight. You are the mystery, experiencing itself from within, a conscious expression of the quantum creativity that underlies all reality. In your awareness, the universe comes to know itself. In your wonder, cosmos celebrates its own infinite potential. In your dreams tonight, quantum possibilities will dance through your sleeping mind, weaving new patterns of understanding that will emerge tomorrow as insights, inspirations, and moments of profound connection to the hidden world that is always there, always creating, always inviting you deeper into the beautiful mystery of existence itself. And so our gentle journey through the hidden world inside the quantum realm draws to a close, though the mysteries we've explored will continue to unfold in ways we can barely imagine. We've drifted together through landscapes of pure possibility, where particles dance between existence and non-existence, where consciousness and cosmos weave themselves into a single tapestry of creative becoming. From the strange behavior of electrons passing through double slits to the profound implications of quantum creativity itself, we've discovered that the smallest scales of reality hold the keys to the grandest questions of existence. The quantum realm isn't just the foundation of matter and energy. It's the source of space and time, the wellspring of consciousness, and perhaps most remarkably, the ongoing creative process through which the universe continuously brings itself into being. Tonight, as you drift towards sleep, remember that every atom in your body, every thought in your mind, every beat of your heart emerges from this quantum substrate we've been exploring together. You are not separate from these mysteries. You are their living expression, a conscious wave in an infinite ocean of possibility, participating moment by moment in the cosmic creativity that generates all existence. Until we meet again in another corner of the cosmos, sleep deeply, dream freely, and know that in your very being, The universe is experiencing its own infinite mystery. The quantum realm isn't just something you've learned about tonight, it's what you are, always have been, and always will be. Sweet dreams, fellow travelers in the quantum dance of existence.